Everybody's attention up here, please. Welcome back. Happy Thursday. Just a couple of announcements before we jump in. Number one, this coming Monday is Columbus Day. That does not affect us, but if you have Monday day classes, they are canceled for this Monday. If you have Monday evening classes, anybody have a Monday night class? They're still on. Says the person who has a Monday night class. Yep. Okay, so that's coming up Monday. Okay, so taking a look at our calendar, we've got kind of a funny couple of classes coming up. Today we're going to cover lesson 13 and start 14. Lesson 13 is our second day of applications of systems. It's just more word problems. These ones are a little bit tougher than the ones from last class. Then we're going to start lesson 14. The thing that's funny about that is that lesson 13 is the end of the material for the test that's coming up. I'll say again, lesson 13 is the end of the material for the test that's coming up. So we're going to do 14 today, and then we're going to come back on Tuesday and we're going to finish 14, and we're going to do all the 15, but none of 14 and 15 is on the test. Okay? Some people get a little bit bothered when we do stuff that isn't going to be on the test. I don't know what to tell you. I could have had the test on Tuesday, but if I did that, that would mean that the test was the class after we did stuff that's going to be on the test, and I always like there to be a one class buffer. Even if that buffer isn't just like an empty review day, at least it's time for you physically to make sure that you get the stuff that we covered today that is on the test. All that said, 1 week from today, October 15, is when our test is going to happen. It's on everything we're covering from day 1 up until the end of lesson 13. We're going to start that test with our normal review time. It'll be about 20 minutes long, leaving about an hour and change for the test. Again, I'm not going to call you together at that time. It's just going to be your own individual review, and I'll walk around and help in any way that I can. Any questions on the calendar? Okay, I think that's it. All right, so before we jump in here, we're starting on page 100. I just wanted to say that in the MyMathLab homework, some folks are running into difficulty when the answers to these systems of equations are fractions. And that happens, and fractions can be perfectly right answers. But the difficulty is that let's say that you're trying to find x and y, right? Because we've got a system of equations. So I'm just going to make something up here. We're not going to do this whole problem out, but just to give you a sense of what I'm talking about. So 3x minus 2y equals 8, and 5x plus y equals 7, something like that. So I just made these equations up. Almost certainly the answers are going to be fractions. I didn't go out of my way to try to make them whole numbers. So let's do the elimination method here. I think it's easier to eliminate the y. What can you multiply the bottom equation by? 2. So let's multiply that bottom equation by 2. So we're going to double this whole thing here and get 10x plus 2y equals 14. And now we're going to add these two equations. So ignore the one in the middle. How many x's? 3x plus 10x, 13x. What about the y's? They cancel. And what do we get when we add the right-hand side? 22, right? So how much is x as a fraction? 22 on 13, right? So that's the answer. That's the right answer. Don't type it in the calculator. It's going to make it worse. You're not going to be able to type that decimal in on MyMathLab anyway. So that's the only correct answer for x. Now, in order to find y, here's what I had said before, and then I'm going to give you an alternative technique, which actually might be a little bit easier. And Brandine shared this idea with me in the studio, and so I want to share it with you guys. Typically, we would take that x equals 22/13 and plug it into either of the original equations that are blue. And that's kind of a lot of work. So if I change in the first equation, I'll change that x to 22/13. So it would be 3 times 22/13. And then I'll copy the rest of that first equation. Minus 2y equals 8. Everyone see what we did? And solving that equation for y is not trivial. You got to really know your fractions to get the right answer here. You got to be able to multiply fractions. Some of you probably are thinking common denominator. That's not what we need, not for multiplying. We just go straight across. But after we multiply and get a single fraction over there, we then need to move it to the other side by subtracting. And in that case, we then do need a common denominator. This 8 is going to have to become something out of 13. And then the last step is going to be to solve for y by dividing both sides by -2, which you've already got fractions at the moment, and then dividing by -2 is just hard. It's complicated. When I presented this, this was the method that I suggested that you use. But Brandine has an alternative. In the beginning, what letter did we eliminate? Eliminated y. So Brandine decided she's just going to start over, go back to the two original equations and eliminate x. And if you do that, you'll have your answer for y. So eliminating x here, not to say that it's easy, but it involves a whole lot less fraction stuff than my method. So eliminating x, we're going to multiply the first equation by 5. We're going to turn these both into 15x, or one of them will be negative. So let's multiply the first equation by 5. So we'll say times 5 here. And the second equation by -3. I'm not going to write all the details. I'll just write this last step here. So 5 times the first equation, 15x minus 10y equals 40. And -3 times the second equation, ignoring the 2, it's in purple. -15x minus 3y, -21. And if we add these equations, what happens? What about those x's? They cancel, and that's the idea. And you'll have a simple equation with y in it. It won't have any fractions in it. Just the very last step, your final answer will be y equals a fraction. But you won't have to play the game where you're multiplying fractions and then subtracting fractions and then taking a fraction and dividing it by a number. Honestly, I think this is much better than the way that I presented. Any questions on this? Okay, so giving credit where credit is due. What do we think? Which way do you guys prefer? A couple of votes for Brandine's method. Other votes? Any votes for my method? I'm voting for Brandine's method. Yeah, I think this is much better. I'm going to start teaching your method starting next semester, so thank you. Okay, so moving on to page 100, let's give this a shot. In this lesson, we continue to look at systems of linear equations. These applications involve mixtures using percentages and travel. These applications are a bit tougher than the ones in our last lesson. Number 1, an auto mechanic keeps bottles of antifreeze, which is the chemical glycol mixed with water, in 2 strengths. So just to be clear, you have a blue bottle of antifreeze. Most of that is water, but there is a chemical in there called glycol, and that's what some people just call antifreeze. It's that glycol. 2 strengths. The first bottle is 20% glycol, which means what percentage is water? 80%. So 20% of it is this chemical, 80% is water. And the second bottle is 35% glycol, leaving 65% water. Which one is more diluted? The 20 or the 35? More diluted is the 20, because the 20 has a higher percentage of water, okay? So 2 different strengths. And the mechanic needs to mix these 2 guys up in order to create a 12-quart solution, still called antifreeze, but it's going to have a concentration of 25% glycol. And that seems reasonable because 25 is in between the diluted 21 and then the stronger 35 one, right? So it seems at least possible that we could mix these guys in just the right way. So that's the goal, is to figure out how much of each bottle should be in the mixture. 12 quarts altogether, trying to build 25%. Okay, so this table's already filled in. We're just going to kind of point to some stuff. There's the question, how much of each bottle? So that's what our variable should be. We'll let L be the amount of antifreeze in quarts. Don't forget to have that unit word. The 20% concentration. And then H is the amount of antifreeze of the 35% concentration. And then we're going to start filling in our table. So L and H are both amounts of antifreeze. That's the first column. That seems reasonable. What's the total amount of antifreeze we're going to have at the end? There's 12 quarts, so the 12 at the bottom there, we buy that. Okay, the percentages are the easiest things to plug in, but what's the only change from the words to the table? We go to decimals, right? So make sure your percentages automatically become decimals. 20% became 0.2. Notice for the first time we have a number in this bottom middle that's been blank for every problem we did last time and every problem in the homework. But now the final mixture here, it isn't like a total per se, it's just a final mixture. And it is given as 25%. So we got to put that in the table right there. As usual, how do we build the last column? We do what to those first two columns? We multiply those first two columns. I'm hoping that that makes sense to you, that that's reasonable. It's not just like a memorized, this is how the table works. You know that that 20% of this first bottle is glycol, and L is the total amount of liquid. Some of it glycol, some of it water. And does multiplying those make sense for figuring out how much of that liquid is actually this chemical glycol? You're just finding 20% of L, 0.20 times L. Catherine. It is, so no, it's not saying 0.2%. It's saying 20%, and then we're writing it as 0.2. The heading could be a little bit misleading if you don't, I mean, we're the ones filling this in, but if somebody else wrote that, I might not be clear. Is that 0.2% or is that 20%? It's 20%. Okay, so we multiply across, 0.2 times L goes here, 0.35 times H goes here. Okay, this is a new calculation for us. Where did that come from? Straight across. Isn't it the same thing we did? We multiply here and that goes there, right? Well, for the first time, we have numbers in both of these bottom row columns. 12 times 0.25, that's what goes there. 3 quarts of glycol is what we're after in the final mixture. And once the table's filled in, writing the equations is almost trivial. First column, L plus H equals 12. Last column, 0.20 L plus 0.35 H equals 3. And there they are down there. We're not going to solve them. Our MO for today is still going to be just set them up. That's the priority. And then when there's time at the end, we'll solve them. Any questions on the setup? Okay. So the last kind of problem is down here. Before we look at number 2, let's just read number 3. Irma flies her plane with the wind and makes a 450-mile trip to Saratoga, New York in 3 hours. The return trip against the wind takes 5 hours. Find the speed of the wind and the speed of the plane in still air. So when Irma is going with the wind, she goes faster, but in the other direction, she's fighting the wind and she goes slower, so it takes longer. And we're just trying to figure out how fast is this wind moving, and if the plane were in still air, not helped by the wind and not hurt by the wind, how fast would it go? All right? So we'll start with our definitions. That right there tells you exactly what the definition should be, right? Find the speed of the wind. Super. Let W equal the speed of the wind. Find the speed of the plane in still air. Great. P equals the speed of the plane in still air. Make sure you include those unit words. In both cases, what's the appropriate unit? Miles per hour, right? And these are speeds. Miles per hour is our unit for both of those. Okay, so let's start talking about this table. We've got 2 legs on the trip. We've got the trip to Saratoga, which was with the wind, and then the return trip, which is against the wind. Don't look too closely in the table. I want us to figure something out first. Suppose that P is equal to 100 miles an hour. That's the plane normally with no wind, and that the wind is 20 miles an hour. When they are both going the same direction, how fast is she really flying? 120. Yeah. When the wind is going against the plane, how fast is she flying? 80. Yes? So all we have to do is figure out how to represent that in terms of P and W. Why was it 120 in terms of P and W? P plus W. Yeah? And so this first column here is rate or speed, and with the wind, or her speed, her total combined speed is P plus W. When we were going against the wind, it was 80. What is that in terms of P and W? Which minus which? It's P minus W, right? It was 100 minus 20. It wasn't 20 minus 100. It was 100 minus 20. So that's P minus W. And the fact is, anytime we have one of these kind of travel problems, it's always going to be the sum of the two speeds when they're working together and the difference when they're working against each other. And I could take the plane and throw it in the water and make it a boat. And instead of wind, what do we have in the water? Current. But it's the same idea, right? If you're going with the current, you're going to go faster than you normally would. If you're going against the current, you're going to go slower. But every time we have one of these problems with travel, it's always going to be a sum in the one and a difference in the other. And if you need a reminder of that, just make two numbers up. It'll be really easy. Oh, we just add them. We just subtract them. Okay, the next column is going to be the time. Now, in this case, the time was 3 hours and 5 hours. So we just put in 3 hours for with the wind and 5 hours for against the wind. Now, that is a moment where a lot of folks go wrong, because they don't really pay much attention to where they put the 3 and the 5. And if you put them in the wrong spots, you're not solving the right problem. In fact, you're solving a problem that's impossible, because if you put the 5 up here and the 3 here, then all of a sudden it took you longer with the wind than against the wind, and you will get some very strange answers as a result. Like the wind will be a negative speed. So pay attention and make sure you're putting them in the right spots. Okay, and the last column here is distance. Now, we haven't talked about how to find the distance, but if we like the idea of the way we've set up all these other tables, how do we fill that last column in? We multiply the first two columns. Is that what we have in this table? Yeah, P plus W times 3, P minus W times 5. Okay, so now I need to justify. Why are we multiplying those two columns? Okay, suppose that I tell you that you go 60 miles per hour for 3 hours. Just making something up. How far did you go? 180 miles. Everybody buys that? So to find the distance, which was 180 miles, we multiply the speed times the time. Yes? Something very natural for us. Written as an equation is here. The speed, or the rate, times the time equals the distance traveled. 60 times 3. And look, in our first two columns, we have rate and we have time. And apparently, we just multiply them, and that gives us the distance. So we set it up in just the right way so that it's still the same pattern. Multiply the two columns, get the last column. Okay, so our equations here, there is no total or mixture row at the bottom. So you just have to make sure you use the given distance. In this case, it's 450 miles both ways. And so on the one hand, this distance is 450. That's the first equation. And on the other hand, that distance is 450. So both of those equations are set up down there. Any questions on that? Okay, one other thing that I want to point out, just a common error. Instead of P minus W, W minus P. Seems good, you just add them and you subtract them. But again, you got to make sure you're careful about that. The wind, I really hope, is not outpacing the plane. We didn't do 20 minus 100. We did 100 minus 20. So just make sure you are careful with the order there. Okay, so I think on the next page are the activities. So I want us to do the same thing we did last time. Set them up, define your variables, make your chart if that's helpful to you. As soon as you've written two equations, move on to the next problem, okay? Don't solve them initially, just write the two equations, move on. Once you've written equations for all the problems in the activities, then you come back and start solving with either substitution or elimination. Raise the flag if I can help.